We are going to write a polar equation for the conic with the givens eccentricity 2.3 and having a directrix with the equation x equals 3. Since the eccentricity is larger than 1, we know we have a hyperbola. And with the directrix occurring at x equals 3, it's of the form x equals d. So we're going to use the standard form that has a plus in the denominator and a cosine in the denominator. So the two options that change is this could be a plus or a minus, and this could be a sine or a cosine. So we're using the standard form that involves the plus and the cosine because of the directrix equation being x equals a positive number. So we're going to put that together. The first part is we're going to use this standard form. In this standard form, it's important to note that neither e that is in this form is the number e. It is simply the variable pertaining to whatever value your eccentricity is. So everywhere we have an e, we're going to plug in 2.3, and then for the d value here, we're going to put what x is equal to. So this is just a substitution problem. So at this point, substituting in for e in both places, I'm putting 2.3 and 2.3. And then for the d, I'm putting the 3. So we're going to multiply 2.3 times 3, and then we're multiplying 2.3 times cosine of theta. So at this point, this is the equation for the hyperbola that we want. If you want to graph it at this point, you can start substituting in values for your theta and then solve for r, which will be the distance from the origin to the point that you want to graph. So you can create what would be analogous to an XY table. All right, I have a theta r table here, and you can put in some angle measures in radians, plug them in for theta here, and then solve for r. Being this is a hyperbola, it's sometimes kind of difficult to see where this extra curve comes from. The dotted line here is my directrix. This first curve is the first 3 points here. I have a point here, I have a point here, and then I have a point way up here. And to get this other point, it's not really clear how this shows up, but if I put in, say, a negative pi in here, negative pi, I would rotate down this direction, coming towards here, but then the radius is negative, so normally I would come out 5.3 as the radius, but since this is negative, I'm actually going to flip that around and it reflects across the y-axis and puts my point here. And so we get this extra part of the curve here by rotating in a negative direction and then flipping over here. And so we get this hyperbola. Cheerful calculations.